Hello students, welcome back to our channel. So in this today's video, I am going to discuss about the atomic structure of intermediate first year. This is the first chapter of intermediate, that means junior inter. This is the first chapter, atomic structure. So now in this atomic structure, in today's video, I am going to cover the introduction part, subatomic particles, and also the discovery of electrons. Now first coming to the introduction part. So in our previous classes, we already learned so many things, so many laws about the structure of atom. So according to John Dalton's theory, the structure of atom is derived on the basis of law of conservation of mass, law of constant composition, and law of multiple proportions. By using these three laws, the definition of atom is the smallest indivisible particle of an element which takes place in the chemical reactions. That means the atom is indivisible, that means incuttable. The smallest incuttable part which takes place in the chemical reaction is called the atom. So every chemical reaction is, that means every chemical reaction, each and every chemical reaction is takes place due to the presence of atom. Okay, so so in the universe we have number of different types of matters. So these different types of matters were due to the presence of different types of atoms present in the element. So in our universe, the different types of atoms combine, different types of atoms combine to form different types of materials or compounds or matter, whatever it may be. So this is the basic definition of atom according to the John Dalton's theory. So now after the Dalton experiments, so there are number of scientists were did their experiments on the structure of atom. So finally, so some people concluded that the atom is divisible. So John Dalton proposed the atom is indivisible, but after the John Dalton's theory, some scientists were discovered the atom is divisible. That means inside the atom there are some particles are present. Okay, so inside the atom there are also some particles are present. Those particles we call them as subatomic particles. We call them as subatomic particles. That means the particles present inside the atom are called subatomic particles. So these experiments are in the 20th century. In 20th century, there are number of scientists did their experiments towards the atomic structure, and finally they concluded that the atom is divisible. That means there are number of small particles are present inside the atom. So these particles are called subatomic particles. Due to the presence of these subatomic particles, different types of atoms are observed. Different types of atoms are we observed. So due to the different types of atoms, different types of matters are we observed in the universe. This is about the subatomic particles and introduction of atom and subatomic particles. So now coming to the discovery of electron. So the electron was discovered by J.J. Thomson. This is the very important point, students. Remember this. Electron was discovered by J.J. Thomson. So he did an experiment towards the structure of electron. So before going to the experiment, we just learn some more few things. So those are, the first, the scientist Michael Faraday, he is the scientist, showed that when the electricity is passed through the electrolyte solution, a chemical reaction takes place at the electrodes in the form of liberation or deposition of matter. That means, when Faraday, he is the scientist, he showed that when he passes a electricity in the electrolyte solution, so after the passing of electricity, he observed that the the chemical reaction takes place at the end of the electrodes. When he passes the electricity into the electrolyte solution, the chemical reaction takes place when at the end of the electrodes, so in the form of liberation or deposition of matter. So by So it results a particular nature of electricity. That means to the liberation or deposition, we find the nature of the electricity. So the particular nature of electricity is we found due to the liberation or deposition of matter. So here the structure of atom is observed from the experiments electrical discharge through the gases. By using this type of process, J.J. Thomson also proved the structure of atom. So before going to the J.J. Thomson experiment, we also know one of the important point, that is the like charges are always repel and unlike charges are attract each other. That means if a plus charges are coming to near each other, they always repel. So if plus or negative charges are always attract. Okay, so like charges are always repel and unlike charges are always attract. This is the these 2 points are the very important. Now coming to the experiment, J.J. Thomson discovered the electrons by using the cathode ray discharge tube. So what is the cathode ray discharge tube and how it arranged? Cathode ray discharge tube, the discharge tube is made up of glass. Okay, so this is the discharge tube and it is made up of glass. It contains two electrodes which are also made up of metals. So the discharge tube contains two electrodes at the end. These two are made up of metals. So the electrical discharge through the gases could be observed only at low pressure and high temperature. This means the electrical discharge through the gases, when we passes the electricity through the gases only at low pressure and high voltage. Okay, sufficient voltage is applied through the electrodes. So these two electrodes are be connected through the battery. When a high voltage is applied through the electrodes, high voltage means nearly 10,000 volts voltage is applied in this tube. So current starts flowing from cathode to anode. Okay, when high voltage is applied, current starts from cathode to anode. So these are called cathode ray particles. The flow of current is observed by fluorescence. So coming to the observations, the cathode rays moving from cathode to anode. So that means the current, when sufficient high voltage is applied to the electrodes, applied through the electrodes, the from cathode to anode, the current is passes in the form of particles. Those are called cathode rays. The cathode rays moving from cathode to anode. These rays are not visible, but their behavior can be observed with the help of fluorescent materials which glow when hit them. When the current passes from cathode to anode, when it hits the fluorescent screen, the behavior is, we observe the particles behavior. So in the, so actually the flow of current is, we cannot visible. By using the fluorescent screen, we observe the nature of the particles. So for example here the fluorescent materials కి ఇక్కడ example ఏంటంటే television pictures are due to the fluorescence on the television screen. So due to the presence of fluorescent on the television screen, we observe the television pictures. This is the example of fluorescent materials. Now coming to the third point, in the observations, in the absence of electric and magnetic field, these rays are traveled in straight line. Okay, in the absence of electric and magnetic field, these rays are traveled in straight line, but in the presence of electric and magnetic field, these rays are traveled towards the anode. That means these rays contains negative charge particles. These particles are called electrons. Okay, so in the presence of magnetic and electric field, these rays are moving towards the anode side. That means these rays contains negative charge. So these are called electrons. Cathode rays, and coming to the another point, that means the fifth point, the cathode rays do not depend upon the nature of the gas in the discharge tube and electrodes, the material what we used as a electrodes. Okay, so the cathode rays do not depends upon the nature of gas and electrodes. So Finally, by observing these points, J.J. Thomson observing these points, he finally concluded that the electrons are the basic constituents of the atoms. Okay, finally, he concluded that electrons are the basic constituents of the atoms. So, this is the discovery of electrons. Once again, I will repeat the total experiments in a short way. J.J. Thomson discovered the electron by using cathode ray discharge tube. Okay, ray discharge tube is made up of glass material. At the end of the discharge tube, one side two electrodes are arranged. One is the cathode electrode and another one is the anode electrode. These two are connected with the battery. So the the electric discharge through the gases could be observed only at high voltage and low pressure. This is the one of the most important point. The electric discharge through the gases only observed at high voltage and low pressure. Okay, next, when sufficient high voltage is, so this is the total arrangement of the discharge tube experiment. So now sufficient high voltage is applied through the electrodes. The current passes from cathode to anode in the form of particles. Okay, the current passes from cathode to anode in the form of particles. So these particles are we called as cathode ray particles or cathode rays. Why we call them cathode ray particles or cathode rays? Because these particles are coming from cathode to towards the anode. That's why we call them as cathode ray particles. So the total movement of these particles were observed by fluorescent coating screen, which is placed at the end of the anode side discharge tube. సో ఈ అరేంజ్మెంట్లో మనకి ఇక్కడ మనకి పార్టికల్ అనేవి మనకి ఇన్విజిబుల్, అంటే మనం జస్ట్ నార్మల్గా మనం విజిబుల్ చేయలేము. సో బట్ ఈ పార్టికల్స్ యొక్క బిహేవియర్ని తెలుసుకోవడానికి, సో యానోడ్ అట్ ద ఎండ్ ఆఫ్ ద యానోడ్ సైడ్ వి అరేంజ్ ద ఫ్లోరోసెంట్ స్క్రీన్. సో వెన్ దీస్ పార్టికల్స్ హిట్ త్రూ ద యానోడ్ it will glow like that. These particles are coming from cathode to anode. Okay, now coming to the observation part. This is the total experiment. Now coming to the observation part. Cathode rays moving from cathode to anode. So first point, the cathode rays moving from cathode to anode. And the second point, the rays are not visible but their behavior is visible by using fluorescent screen. So these fluorescent screen materials ke example vachese television pictures. Next, coming to the another point. In the absence of electric and magnetic field, the rays are traveling a straight line. But in the presence of electric and magnetic field, the rays travel towards the negative electrode. That's why we call them as cathode rays. Okay, so due to the presence of this negative charge, these are called the electrons. So cathode rays, and another most important point, these cathode rays do not depend upon the nature of the gas as well as the nature of the electrodes. Next, coming to the final conclusion. So after this experiment, J.J. Thomson concluded that the electrons are present and these are the basic constituents of all the atoms. This is the final conclusion of J.J. Thomson discharge tube experiment. So guys, this is the today's video. In the coming video I am going to discuss about the charge to mass ratio of electrons. So if you guys like the video, please subscribe my channel and thank you for watching.